Hello, everyone, and welcome to today's Skillsoft Bootcamp, Executive's Guide to Secure DevOps. I'll be your host for the next hour or so, and I'm going to start sharing my screen so you can all participate. So as I mentioned, we're talking about the Executive's Guide to Secure DevOps, and I'm your host, Ed Adams. I'll be talking for the next 45 minutes or so, and we should have plenty of time for audience questions at the end. For those of you that don't know about Security Innovation, the company that I work for, we are a partner of Skillsoft. Skillsoft, you can get all of our training and education assets through the Skillsoft Percipio platform. But just so you know who we are, we've actually been around since September 2002, and our focus since then has been securing software in a whole bunch of different platforms. We've literally tested satellites, Harley-Davidson motorcycles, cement trucks, breathalyzers, and of course, a lot of mobile web and cloud applications. Our 18 years of testing software and helping our clients remediate those vulnerabilities led us into launching an education business, which now has put through 3 million users. And we also, in the process, authored 18 different books, or co-authored or authored 18 different books. And for 6 years in a row, we were on the Gartner Magic Quadrant for security training. For those of you that don't know me personally, I am the president and CEO of Security Innovation and have been since October 2003. I also host a monthly talk show called Ed Talks, where I bring 3 cybersecurity experts together and we discuss relevant and current cybersecurity topics. I sit on the board of directors for the International Consortium of Minority Cybersecurity Professionals, otherwise known as ICMCP, and I'm a research fellow at the Ponemon Institute. All of those things you will notice revolve around one thing, and that is cybersecurity. That's been my life for the past 18 plus years. What we're going to be talking about today, 3 major categories. I'll start by talking about DevOps versus traditional approaches. Then we'll spend the majority of our time talking about DevSecOps in practice. And finally, in the last sector, we're going to be talking about how to get ready for or prepare for DevOps. Now, just so you all know, this is not intended to be kind of a how to learn or implement the DevOps. What this is about is a higher level education for folks to understand what DevOps means and how it might be different from traditional software development and deployment life cycles, with a particular focus on security. Now, I'll use DevSecOps for the most part today, but other folks like to call it Secure DevOps, or I even talked with one CISO that said, can we just call it DevOps and just make security part of the quality process, which I actually am in favor of, but you will hear me use DevSecOps for the most part. And DevOps as a practice, it basically promises faster release of software with more consistency. And that improved consistency includes a lot of collaboration, communication, and streamlined feedback, because without that feedback, you're not able to address a lot of those quality issues that enable the rapidity of software development and deployment. Now, one thing that DevOps is similar to from other software development methodologies, whether it's agile or rational unified process or waterfall, pick your favorite development process. You can't skip steps. DevOps has 8 basic steps that they sort of organize in a figure 8 most commonly. I chose 7 out of those 8, and I put them in more of an assembly line visual because that's how I like to think about it. Now, what happens in DevOps is you run through that assembly line very quickly, and a lot of times you'll be iterating multiple times within one station. But the point here is that you can't skip any steps when building software. Just like you can't skip steps when you're building a house. You still have to design the house, you still have to construct the house, you still have to test the house, and you still have to maintain and update the house, just like with software. So with DevOps, you've got to do planning, you've got to do some coding and building, testing, the release, maintenance, the deployment, monitoring, all of those elements still have to happen. But the focus on DevOps is moving quality efforts earlier, otherwise known as shifting left. But I do think of DevOps as an assembly line. And just like a traditional assembly line, sometimes you need to cover for the station on to the left of you or the station to the right of you. That means you'll need more cross-functional skills. It becomes much more important. With this emphasis of early stage and iterative development, if you're in the build team and the test team is over capacity, they don't have enough cycles, you might have to pick up some of their testing. But you also have to understand what the test function is doing and what the code function is doing before you, so you can effectively communicate with those folks. And again, the promise of DevOps is to be able to take feedback and input all the way from the customer, which is as far right as you can go, all the way back through to the product owner, which is as far left as you can go. The product owner does a lot of the planning and managing of all of these iterations. Now, what DevOps also means is that you can have easy to audit configurations. One of the wonderful things about DevOps is that high level of communication and documentation makes auditing a little bit easier if it's done appropriately. And it also allows for tremendous scale and easy rollback of configurations because you've got much smaller iteration cycles, much shorter build and deploy cycles. So being able to roll back if someone breaks the build, as it's known, is a little bit easier to do. However, all of those traditional activities don't go away. You still need to perform security code reviews and penetration testing, and you have to do deployment reviews once your application is deployed. Now, the form of those might change. A penetration test, you might be running a longer penetration test in parallel to doing individual testing at the code phase, at the build phase, at the release phase, etc. But they don't go away. Now, I also like to think about in the DevOps model as everything as code. Now, today, infrastructure as code is a very real thing. Servers are usually virtual machines. Containers are basically virtual machines for individual applications. The entire software stack is typically software, but a lot of networks these days are also software. You're releasing infrastructure as code with a lot of the cloud providers. Now, thinking about everything in terms of software, to me, makes the world easier to visualize, easier to reproduce things more quickly. And also doing so, it does allow for things to be more editable and auditable and accessible. Now, you are going to have some new terminologies and some new tools to be able to get familiar with, things like Docker files, Chef cookbooks, and stuff like that. But cloud configuration files, digital certificates, hardening scripts, configurations for firewalls and web application firewalls. Thinking about a lot of them as code, and by the way, many of them are actually software, will allow for this very easy sort of modular way of being able to assess and rework things that you're doing. So let's talk about DevOps in practice. Now, what I'm planning on doing here is I'm going to take these 7 steps, and I'm going to I think I'm talking about 6 out of the 7. I don't think I get into release very specifically, but again, by design, I'll refer to it along the way. And I'm going to tick off each one of these 7 in the next several slides. But I want to start with planning, because to me, this is the most important phase. And a lack of planning in DevOps will lead to slower throughput and the inability for team members to collaborate and communicate with a common set of objectives and metrics. And that is really the promise of DevOps. That's what DevOps is saying we can be doing at greater scale and at faster. And again, just like building a house, you don't show up to the job site with a bunch of wood and nails and a hammer and just start hammering. You need some type of blueprint. And what type of house are we building? What size? What are the sizes of each room? How are they shaped? And you also need to define gates, so it's very clear when the current phase is complete and you're able to move or pass on to the next one. And the planning stage for DevOps is similar to any other security planning. You do have to think about things like threat modeling, policy development, and security assurance models. But in DevOps or DevSecOps model, planning is where you set the stage for integrating security into even the deployment pipeline, which comes much later in the cycle. Now, you're going to hear me talk a lot about planning and policy throughout this presentation. That might surprise you, but I cannot stress enough how important it is to do this planning in advance, because once you've got the plan, you set the team off running and you want them to be running fast. And if your plan doesn't have some critical steps, or if it's not detailed enough, things will get missed, and then you'll need to go back and iterate the plan, which you should be able to do fairly quickly, but you also need to manage scope. So when it comes to security in DevOps, the challenge is to get just enough security, but not too much, and don't overwhelm folks. One very common pitfall that I see with a lot of organizations that move to DevOps is they adopt too much automation too quickly. And what that does is it overwhelms most of the team members, regardless of what phase you're at, with a whole bunch of security alerts and false positives. And what do those do? They waste time. And it causes each team member to take focus off of their primary objective to go and investigate that alert. And if the alert turns into be a false positive, actually not really an alert, but just something that an automated tool flagged, you've literally wasted time. So integrating well-defined checkpoints that are both specific and sufficient to each phase, without rushing into automation, is a really, really important thing to focus on. Now, I also want to talk a little bit about acceptance criteria here. And acceptance criteria can also be thought about as a critical element to a service level agreement. Now, when a lot of folks think about service level agreements, they think in terms of your organization or enterprise in relation to an external third party. You have a service level agreement with that third party that says, let's say you've hired them to build an application for you. Here are all the features of my application, and you go and build it. And when it comes back, there's a set of acceptance criteria that I will test against. And if any of those criteria fail, it's going back to you so you can fix it at no additional cost. And then it comes back to me, it comes back again, and we'll go through the same test acceptance criteria. Now, in order to do this with security, you need to have a security defect classification system. Now, almost every software development team has a defect classification system. However, security often is not integrated into that. So let's say, for example, you have an acceptance criteria that says, I will not accept any level 1 security vulnerabilities. Well, what is a level 1 security vulnerability? You have to define that as part of a security defect classification. So in order to have these acceptance criteria, you need to have a security defect classification system. And if you have a defect classification system for functional bugs and performance bugs, and a separate classification system for security defects, you're on a collision course, and you really need to unify and normalize that language. Because you remember early on, I referenced a chief information security officer who said, can we just call it DevOps and just have security be part of overall quality? And I think that's a fantastic idea, because it really is part of software quality, just like functionality and performance. So the safest way to integrate security is to spread it out across the entire pipeline. So each stage has a natural and incremental security checkpoint that they know they can pass through before handing the software off to the next phase or the next team. Okay, next I want to talk about coding. Now with coding, we're sitting here in June of 2021, and the modern application is really not coded from scratch anymore. In fact, I'll talk about on the next slide. Typically 70 to 90% of an enterprise application is actually assembled from third-party components and open source software and other libraries that get pulled in from different areas. So applications are generally not coded from scratch anymore. Now, there is coding that goes on in DevOps, of course. So you have to make sure that coding is done in a secure manner. However, that's just one small element of the coding phase. The coding stage also provides many opportunities for the environment in which code is built and deployed to be insecure. So you've got to secure your virtual machines. You've got to ensure those secure those containers. All of those the virtual private networks that your organization might be working in. And today, a software engineer can spin up an infrastructure very quickly, run some testing, and then tear down that application or that infrastructure and determine whether or not it was sufficient for the need that they're trying to or that particular function that they're trying to build. But all of that infrastructure that gets spun up very quickly needs to be done in a secure manner as well. And knowing how to handle what's known as secrets in DevOps, which could be passwords, they could be API keys, they could be certificates, it could be authentication credentials. All of those need to be handled and managed in a very secure manner. So you're avoiding things like hard coding secrets, in leaving test credentials in production code, which happens all the time, by the way. Might sound silly, but happens all the time. So in the coding phase, think well beyond just securing the code. Think about what that code exists in, how it's compiled, how it's deployed. You also have to secure all of those elements around that. And finally, this last bullet about determining a defect saturation that breaks the build, going right back to that policy and the plan that I talked about a couple of slides ago. At the code phase, you have to determine what level of acceptance is okay, which, how many defects, how many level 1 defects versus level 2 defects. What is the saturation of security defects I'm willing to accept before passing it on? Basically, set a bar, and if your saturation goes beyond that bar, break the build, go fix what broke the build, and then continue on with your iteration. Now here's that reference again to the build phase. This is the assembly phase. Here's the statistic that I think was taken from the open source security research done by Synopsys, where between 70 and 90% of enterprise applications are actually assembled from third-party components or open source software. So that means that only 10 to 30% of a modern enterprise application is coded by your software engineers with unique code. That's a very, very small percentage. And this is where things like SCA or software composition comes in to be really, really important. You need to make sure that those third-party components, those open source software components, are up to date and patched. And once again here, great time to gather some metrics to figure out what is going to break this, break the build. At what point do I say, okay, this level of high risk vulnerability, it's too important, so stop the build. We have to fix this particular vulnerability and then move on. And of course, in order to set that level, you have to have that defect classification for security vulnerabilities, which I mentioned a couple slides ago. So keep in mind that third-party components and open source software are making up the vast majority of enterprise applications. And also, for those of you familiar with the recent SolarWinds attack, SolarWinds, first of all, they were compromised during the build phase of their own product development, but then they took that product that had malware in it, shipped it off to their customers. Their customers like the Microsofts of the world and a lot of the US federal agencies of the world. And those organizations need to look at that as a third-party component of their software supply chain and treat it as such, with appropriate sandboxing and appropriate checks to determine whether or not it's fully patched, it's updated, etc. So that's really, really critical in the build phase, is to check for vulnerabilities in these third-party components and dependencies, because you're pulling in a lot more than you might actually realize. Next is the test phase. And the test phase, for me, in an ideal world, you may have noticed in my introduction slide that I come from the mechanical engineering world. And in the mechanical engineering world, we had a very similar process to what you see up on the screen here, plan, construct, test, release, etc. But our test phase was called validate, because ideally what you're doing in the testing phase is just verifying that everything you've done in previous phases has been done correctly. It's really a validation and verification process, not a defect discovery process, which is what a lot of organizations utilize it for. Now, with testing, there's a lot of automation that can be put in place. For example, you can use a static analysis security testing tool to scan source code, whether it's source code that your software engineers have written or open source software that you've pulled in and you have access to. You can also use dynamic application security testing automation for testing in the compiled or deployed environment. You've got other types of testing as well. One of my favorite happens to be fuzz testing. Fuzz testing, all that means is you're giving the software input that it doesn't expect. So, in a field that asks for username, try a 25 character string that has numbers and special characters like single quotes and question marks, and see how the application or the software reacts. That's fuzz testing. Now, but also keep in mind, you are just before the release phase here. So now you have to start thinking about testing for cloud configurations. The scripts that are going to be used in deployment or to deploy the software itself, certificates, identity and access management controls. And if you're deploying to the cloud, some of those identity and access management controls might not be yours. You might just use the AWS IAM features right out of the box. Well, you still got to do some testing to make sure that you've implemented those correctly, because if you haven't, chances are you're going to introduce a security vulnerability, even though that is a third-party software component. It's still your data, your software, and your responsibility at the end of the day to make sure that you have deployed and implemented all of that correctly. So think about it again as validation. Next, jumping down to deploy, skipped over release very quickly. Essentially, when the software is ready for deployment, the release team goes through its sets of checks and essentially gives it the green light to say yes, it's ready to go on. And once that application is passed testing and approved for deployment, the security team will need some triggers to perform any deployment related security steps, and this might include creating or updating secrets that are necessary for deployment or operations, documenting what was updated and by whom. Again, very important for auditing. What should we be logging? What can we be logging? Performing any final configurations or hardening checks, determining the authenticity of any third-party applications or components. And speaking of that, by the way, it's very, very common for in enterprise to have many different versions of the exact same open source library or third-party component, which if you take a step back and think about it, it sounds absolutely crazy, but it is extraordinarily common. You might have a particular authentication library written in Java, downloaded from GitHub, open source repository. You might have 5 different versions of that floating around your enterprise, used in different capacities. Well, that makes it makes updating an absolute nightmare for you, but you're also guaranteed to be not using the latest and greatest version of those libraries. And again, this is where software composition analysis becomes very useful. And I'm reminded of a tenant from Edward Deming's, very famous quality professional that really helped Japanese automotive manufacturers with their quality issues. Essentially, the tenant says use only the best suppliers and use only the best parts from those suppliers, and that will help drive a lot of the additional quality into your process. And that's exactly opposite of what a lot of organizations do with respect to third-party and open source software. Now, and again, a quick tip at the bottom here, there are plenty of generally accepted deployment checks, but they do need to be contextual to your environment, to your data, and address all of those planning and policy controls that were discussed a little bit earlier on. Okay, and this last phase, and I say last, air quoting, is because I'm thinking about it as an assembly line, to keep in mind you've got iterative steps along the way. This is where those feedback loops. That's a big part of what makes DevOps really work and work at scale and at speed. So, in addition to those traditional error logs and bug reports, this is where you also want to be defining what types of user-reported metrics we should be tracking, what type of automated vulnerability testing, should we be collecting from the antivirus and intrusion detection systems, the security intelligence, event management, or SIM alerts. This feedback loop takes you back to the beginning of that pipeline where you repeat the process all over again. And then, regarding policy, this is where you are really testing those policy controls that define what you should monitor and log, what you're able to monitor and log, what pieces you have direct control over versus a leased, cloud infrastructure, for example. So, this operate and monitor phase has become incredibly relevant and important in a DevOps world, or as well as in a continuous development, continuous integration world, or CI/CD world, because you might have new versions of a particular software application coming on a daily basis. So being able to monitor, report, and track necessary changes becomes really very, very important in being able to get that all the way back, as far left in the process as possible. All right, the next and third piece, I'm going to be talking about getting ready for DevOps and making way for DevOps, or as this picture shows, making room for DevOps. It's taken from the famous children's book, Make Way for Ducklings, based in my hometown of Boston. We can also make way for DevOps. And I've listed 7 things here that you should be considering as you're getting ready and preparing for the adoption of DevOps, or if you're looking to accelerate what you're presently doing. Those 7 things are listed right here, and I'll be talking about them in turn, some in more detail than others, but I'm going to get right back to starting off with that third-party software piece. In talking about commercial off-the-shelf software and open source software, which is what COTS and OSF stands for, I like to adopt a model of thinking that you are co-owning that software. The fact is, you don't own the software. It's commercial, which means it's someone else's property, or it's open source, meaning it's kind of everyone's property. But if you think about yourself as owning it, because after all, you're integrating that commercial off-the-shelf software and open source software into an application that you will call your own. So if you think about co-owning it, it helps to work through this DevOps process. And let me just take a few examples here. So in the build phase, you might not be building at all. In fact, you might deploy with SAP or Salesforce.com. So you might actually be procuring or buying that particular component or COTS for the build phase. For the again, the code phase, a lot of your code is going to be open source, taken down from GitHub. For the test phase, this is where those service level agreements become highly relevant. And I mentioned them a little bit earlier. Service level agreements basically define what this test phase should expect from the build phase and what the release phase should expect from the test phase, so they can understand how to accept something and how to pass along something. And by the way, service level agreements don't have to be just between yourself and a third party. It's completely legitimate and acceptable to have service level agreements between internal teams. That way, in this case, the release team knows exactly what to expect of the test team, and the test team knows exactly what to expect of the build team. And if Any one of those teams doesn't meet the service level agreement, it breaks the build, returns to the previous phase, and then things continue on. And those service level agreements can continue all the way through the operation and the monitoring phase. Many enterprise applications today are deployed on leased cloud infrastructure using cloud services and APIs. Again, that's all commercial software, it's not your own. So make sure that you're thinking about all of those service level agreements. And remember, it is, at the end of the day, your data and your responsibility, which means you still need to document each one of these steps. You still need standards to follow along the way, and you need those service level agreements, those plans, and those policies to ensure that as you're adopting DevOps, you're doing so in a secure manner. Now, in terms of assessing third-party or commercial off-the-shelf software, this is something that can sometimes be tricky because you don't always have access to the source code. So, we talked a little bit earlier about static analysis security testing, or SAST. You might not be able to at all, especially with commercial off-the-shelf third-party. And you certainly don't want to be reverse engineering, software from SAP or Salesforce.com. Typically, that is a violation of their user agreement. Depending on where you are, it's illegal. So you have to come up with other ways to do it, or kind of black box assessments. You can't just rely on patching. You do need to anticipate the deployed scenario. And again, referring back to Deming's, using highest quality components from the highest quality providers. That kind of concept of single sourcing and making sure that you don't have a mismatch of the same components of different versions throughout your organization. Now, when you don't have access to the source code to address vulnerabilities, you'll have to do so in different ways. So let's say you are using an SAP application as part of your solution, and you find a security vulnerability that you've attributed to SAP. Maybe it's susceptible to SQL injection or something like that. You have to, again, consider the deployed scenario. How can I mitigate a SQL injection vulnerability in a commercial off-the-shelf software that I don't own? And this is where threat modeling becomes incredibly important. So if you've done some of that threat modeling early on, you could actually anticipate for any purchased commercial off-the-shelf software, if I have, or if we discover a SQL injection vulnerability, for example, we'll need to initiate the deployment of a web application firewall to filter traffic and mitigate that SQL injection vulnerability, just as an example. And the cloud, for all of its phenomenal scale and turnkey operations, also provides a plethora of new attack surfaces that can be exploited. And there's a lot of education that needs to go into your team before you adopt new cloud services and deploy your applications to the cloud. Because some of those cloud service providers don't exactly do a fantastic job documenting all their features or giving you implementation guides for security. So a lot of that is on your team. So you've got to go through those threat modeling exercises, those tabletop red teaming exercises to make sure that you can collect the information that you need. You are considering those deployment configurations. And when it comes to applications in the cloud, by the way, misconfigurations is the most common security vulnerability. Again, that's nothing that your team has built. It's all on how your team has deployed your application and configured it using cloud services. It's the most common security vulnerability. Now, all this information gathered from assessments, whether it is static analysis, dynamic analysis, security code, cloud configuration reviews, etc., you can use that to improve the supply chain management and supply chain procurement process. And you absolutely should, because remember, going back to that sort of figure 8 DevOps diagram, you might be, instead of building, you might be using commercial off-the-shelf software for the vast majority of what your application is. And that the information gathered from the assessments can serve as the foundation for a lot of the service level agreements that you might want to put in place, or at least conversations to be had between yourself and third parties, or even internal different teams. But without conducting the assessment and collecting the data, you are not able to improve that supply chain quality or even have those conversations around service level agreements. Now, also keep in mind, we've alluded to some new skills that might be needed. Your development team might be using completely new development languages like React, for example, or they might decide that they want to move to Ruby on Rails because it's the most appropriate for the use case that you're trying to execute. Well, they might need some education just on those platforms themselves, which, by the way, they can get from Skillsoft, but also on how to build with Ruby on Rails or React securely. You'll also have a lot of new phrases and terms to be familiar with, things like microservices and containers and orchestration. These are all new things that have come about in a massively scaled way over the last 5 years as organizations have moved to a CI/CD or DevOps environment and embrace the cloud to help fuel that. The containers, as I mentioned earlier, it's basically kind of a virtual machine for a specific application as opposed to a virtual machine for an entire server. And then if you've got a lot of containers, which many organizations do, it's typically hundreds of applications that run an enterprise, and they're all deployed in containers, you need some way to manage all of those containers, and that's really what orchestration is all about. So there's going to be a lot of new skills required on your team for DevOps. And not only new skills, there's new roles. There are new titles that exist in the DevOps world that previously either didn't exist or meant things very different. Things like product owners, site reliability engineers, DevOps engineer itself is a common one. And a DevOps engineer might exist all the way to the right and might exist all the way to the left. And then because DevOps has such ample opportunity for automation, many organizations are introducing the concept of an automation engineer. That's all this person does is decide which automation is appropriate for various phases. They might be operating those automated tools, conducting vulnerability scans, etc. So keep in mind there are new roles, there are new skills that you need to either source or refine, and especially with the adoption and advent of the cloud, a whole new world of attack surface and services to be familiarized with. Now, just a couple of tips when it comes to DevOps. There's a tendency for software engineers to kind of become, this jack of all trades, because as roles do bleed into one another and the need for heightened collaboration it becomes really important, you do run the risk of kind of watering down more technical competencies. Even though a software engineer that's typically a developer writing code and integrating components can spin up a complete AWS infrastructure, doesn't necessarily mean you want that person doing that on a regular basis. So keeping folks focused in their swim lanes, but familiar enough with what's to the right and what's to the left of them is definitely a best practice that we've seen work in highly efficient organizations, trying to avoid this jack of all trades, which becomes a little bit too dangerous. Also, you don't want to make everyone a security expert. Having a base set of knowledge that you can share, getting the entire team aware of the importance of software security, regardless of what phase they typically operate in. That's absolutely good practice. And then rolling out specific training content for each role. So definitely not want to make everyone a security expert, because most folks on the team have a primary job function that is something other than security. And we'll talk a little bit more about that on the next slide. And then finally, consider this evolving developer role. As we've talked a number of times today, developers are using open source libraries. They can and often do spin up servers and containers, and so the training that you need when it comes to DevSecOps needs to go well beyond writing secure code. And again, writing is in air quotes because It's only about 10 to 15% of the time of what they're doing is writing code, as opposed to integrating third-party components. Okay, so a concept that's been around for a long time is the concept of security champions. But when it comes to DevOps, Gartner actually published a report last year. It's called the 3 Steps to Integrate Security into DevOps. And this chart on the right-hand side is taken straight from that report. What Gartner recommends doing is developing, I think they call them security coaches as opposed to security champions. It's absolutely the same thing. But what they recommend is you find in each individual group, whether it's a software development group, whether it's an IT operations group, whether it's a monitor and operate group, find an individual, starting with just one person, that has a penchant for security, and then train them up on security in their specific roles, so they can serve as the main point of contact within their group. And this helps because they already speak the same language of that group. Let's say it's an architect group, or it's a development group, or it's a test and QA group. So you've got peers talking to peers. And what the security champions can do is help define what those roles and responsibilities are. They can lead a lot of the security reviews, which again are those gates. So they know whether or not they're ready to pass along to the next phase. And ideally, they're passionate about not just software engineering in general, but also security as an aspect of software quality. Now, you'll note what Gartner recommends on the right-hand side is basically a belt system similar to martial arts, where you've got a blue belt, a purple belt, all the way up to black belt. And then what Gartner does is recommend for each one of those belts, there are 3 different elements that happen. There's formal training, or whether that's online or computer-based. There's kind of hands-on activities. They're recommending here, competing in a CTF, which means they capture the flag. Essentially, in today's world, that's cyber range activities, hands-on cyber range activities. And then they actually recommend on-the-job tasks, which is the practical piece. So you've got the formal education, training piece, you've got the hands-on cyber range exercises, and then you've got the on-the-job practice. And the combination of the 3 meet that particular belt level set of knowledge, skills, and abilities in order to sign off on that belt. Now, of course, the training content, the hands-on cyber range activities, all of that can be sourced straight from Skillsoft. That's the business that they're in. That's why we partner with them as their lead cybersecurity content provider. Now, I'm going to reference a second industry report. This one was done by the Ponemon Institute. What the Ponemon Institute did, and this was published also last year, they assessed, I think it was 500 plus organizations on 17 different key elements for effective cybersecurity training. And they took these 17 elements and they measured which ones were more or less effective. And they used something called the Security Effectiveness Score, or SES, which has been around for a number of years, has been validated as an independent measure of maturity. So what they did is, they looked at these 17 different aspects, and you'll notice that the one aspect out of the 17 that yielded the highest return on investment was training that includes realistic simulation. Well, that's exactly what Gartner's talking about in that second column, those hands-on activities, the CTF activities, the cyber range activities. That's exactly what realistic training is all about. And you can see the quote from Dr. Ponemon on the right-hand side. Now, you'll notice the second highest ROI is training content that fits the learner's job role. So you combine role-based training with training that includes realistic simulation, and you've got the 2 most effective elements out of the 17 that were studied for effective cybersecurity training for software teams. And again, that's something that I highly encourage you to take a look at and review as you're considering which training elements to roll out for your DevOps organization. Now, you've heard this before, how good security hygiene begins with good policy. This will be my last well, maybe my second to last slide on policy. The only reason that I bring it up here is because we've covered a lot of ground in the last 45 minutes, and hopefully you've been able to see how defining effective security controls in advance based on those plans and those threat models and attack scenarios that you've conceived of early on really can help grease the chutes of efficiency and communication. It helps normalize language. It helps get you ready for any compliance audits that you might have, because you might have to consider, some new privacy controls, or the California Consumer Protection Act, things like that. But also, policy controls. When it comes to DevOps, there are some very particular and methodology specific things that you need to consider, like the protection of secrets. Again, these can be identity and access management keys. They can be credentials. They can be certain data types that shouldn't be deployed in the cloud. So if you have a certain data type that you don't want to send it to the cloud, or you only want to send it to the cloud after it's been properly encrypted, you might want to consider something like a DLP solution as part of your deployment and data leakage protection. But again, all of that can be driven from the policy. So I highly recommend you go through that planning process and spend the appropriate amount of time developing those policies, and tailor them for this new DevOps world. For example, consider setting policies around how the company should be using Amazon's identity and access management feature, which I alluded to a little bit earlier. You can make specific policies around how identity and access management users and groups can be configured and used. You can use the doctrine of least privilege and design access control policies around that. You can also consider policy where only a few users have trusted full admin access, and others are in a power group where they can launch instances but can't alter AWS console configuration or other accesses. You might want to give your accounting team limited access to the console, and as well as review billing and usage. And while you're at it, develop specific policies around the use, the distribution, the storage of cloud API keys. Because that might be something that's completely new to your team as well. The consumption of cloud services a lot of times means you need to be consuming APIs that have been built by Amazon or Google or Microsoft. So you might as well create a policy around appropriate usage, distribution, and storage of those API keys. And we've talked a lot about commercial off-the-shelf supply chain acceptance testing policy, understanding culpability that you might be exposing yourself to while using commercial off-the-shelf. So again, I'll just leave you with that last recommendation of making sure that your assessments are done at each checkpoint and using appropriate either automation or manual efforts. And I actually like using both. I love utilizing automated pattern matching, whether that's static analysis or dynamic analysis, because they're both fundamentally pattern matching tools, with more complex human-driven things like penetration testing and red teaming that can elude an automated pattern matching team or a pattern matching tool. And you can absolutely run these in parallel as you're going through your DevOps process, whether you think about it as the assembly line like I do, or you're thinking about it as the classic kind of figure eight. So with that, I'm going to wrap up with a summary slide, and then one slide about how Skillsoft can help, and then I can address a couple of questions perhaps that have come in. So I'll start with this summary. I've been talking for nearly 50 minutes, and I'll leave you with Secure DevOps. It does address a number of issues in present-day software development. Lack of cross-functional knowledge, which is really important. The normalization of language, streamlining of communications. The fact that a lot of development teams view security as a tax, and that it'll slow down their ability to get features delivered sooner. DevOps addresses all of those. However, success of DevOps relies on on these three principles, which, by the way, are my principles. They're not taken from any DevOps book like the Phoenix Project. These are really my kind of recommendations to you as far as what to implement to make sure that your DevOps implementation is a success. So one, automate what can be done faster than humans. And again, we've talked a lot about automation here. Whether it's static analysis for open source or code that you write on your own, or it's utilizing orchestration tools like Kubernetes to manage all of your containers for your applications. In combination with that, also understand where those manual efforts are needed, because automation, it can't solve all your problems, and as we addressed earlier, can create an overwhelming amount of information and false positives that end up slowing down your development life cycles and actually derailing the promise of DevOps. So that balance of knowledge, tools, and processes is critically important. If you're deploying tools and your team doesn't have the knowledge on how to use those tools, or your team has been trained on how to securely configure and provision AWS services, then your process is going to fall down. Your process is going to slow down. So balancing those tools and knowledge and the processes that you built around that, definitely one of my three core principles. So how can we as Skillsoft and Security Innovation help? Well, again, referring back to that Gartner chart, these two columns align directly with the first two columns in that Gartner chart. You can get training from Skillsoft on all the various roles in the DevOps world, as well as all the different tech stacks, whether it's infrastructure as code, containers, orchestration, specific to various platforms like AWS and Azure. Skillsoft has over 200 software security training modules that you can use to get that role-based training that is identified as one of the critical elements. Also, you can get through Skillsoft access to software security cyber range. And this is that second piece of what Gartner's talking about, the importance of hands-on, capture the flag type of activities. This is the experiential learning. So you've got the classic online training, and then you have the hands-on experiential learning. And the cyber ranges that you can source through Skillsoft, there's nothing to install. It's all cloud-based. They're actual live applications with a series of vulnerabilities, so they can actually practice those capture the flag activities. And there are challenges that are available for all members of the DevOps team, whether it's those that are building software, those that are operating software, or those that are primarily tasked with defending software. And just one last slide on the cyber ranges that you can get through Skillsoft. There are 7 of them presently, including one that is available for free. It's a kind of a cut down version. And with these, you can choose appropriate ranges for your business application. Maybe you want an easier banking website, or you want a more challenging advanced banking website. You might want to use the single page application because you're building a single page application, or the mobile range because you're building a mobile application. We've got a lot of environments to support exactly what you're looking to do. And it's not easy to build out strong DevSecOps team without this hands-on experience. So whether it's a cloud, web, or mobile environment, this learn by doing concept really works. And I know Percipio has multimodal learning environments that they've been proving out for years. The cyber range that we offer is in the exact same vein. So with that, I'm going to stop sharing my slides, and I'm going to get back to some of the questions that I've seen come along. Okay. Okay, so I will, so hopefully I've addressed some of these, but so first of all, a question came in from the audience. Role-based training and scenario-based training on cyber ranges will vary from one dev team to another, depending on what types of technologies and languages they use. Absolutely. Thank you for that, Dina. What tips can you give on SecDevOps training requirements gathering? Well, First of all, understand what roles you need trained, understand what technology stacks you're using. So as we were talking about earlier, you might have Ruby on Rails, you might be using a Google Cloud platform with Kubernetes. So understanding both the role-based elements of your team as well as the tech stacks that your team is working with. You combine those two together and then go source that. My guess is that pretty much everything that you will need can be covered by what Skillsoft presently has. And then there's also the concept of a skills assessment and a training needs analysis, and that's something that Skillsoft has been doing for a number of years. And that will really round out exactly what you're looking to do, and whether that's part of the pre RFP process or it's just part of your engagement with your Skillsoft team already. I think that's well within their wheelhouse to do. But I highly encourage you to, as part of any DevSecOps training, make sure that you've got this hands-on piece. That's a real critical component of it, because as I talked about in the very last slide, it's tough to get DevOps working properly if you don't have those hands-on elements. So definitely recommend that. So one more question, and then I'm going to turn it back over to the Skillsoft team. This question comes in from, let's see, here it is. There's a lot of confusion on traditional role of developer and operations and security teams and how each feels empowered in DevOps world and tries to do the other's job or delegate their job to the other. How do you resolve that? Yeah, and this is, there's a great point that's brought up by this particular audience member. I go back to that, the internal service level agreements. I think they're very powerful. They don't have to be really large monolithic documents. They can be very short elements that defines, as you move from phase 1 to phase 2, whether it's the build phase to the test phase. These are the gates you have to pass through. This is how you know that it's ready to get passed on. This is who you pass it to. And on the other side of that, you've got the acceptance testing criteria as well. I think that works extremely well. It forces conversations to be had, sometimes difficult conversations about whose responsibility it is to security test, a built component or built element. Well, that's a great conversation to have. And so I think those service level agreements are a very powerful thing. And again, it doesn't have to be internal, it doesn't have to be external, it can be either or both. Okay, and with that, we're almost at the top of the hour. Thank you all. Hope you have a wonderful day.